Dear students, you are welcome. Today we will study isotopes from chapter 2. Okay, chapter 2 atoms, elements, and compounds. 2.3 isotopes. This is our syllabus. This element is called sulfur. Sulfur has two figures. Sulfur S1632, S1633. What's the difference between these two figures? They have the same atomic number. Look, please, for the symbol X or S in this case, the atomic number, okay, equal number of protons or ID of the element in periodic table. So they have 16 protons. These two forms, each one has 16 protons. Okay, what about the above figure? The above figure or higher figure, here 32 on the left and 33 on the right. What's the difference? They differ in mass number. How we calculate number of neutrons? As you know from your previous study, we calculate number of neutrons by certain equation or mathematical subtraction. 32 minus 16 equals 16 neutrons. 33 minus 16 equals 17 neutrons. So they are differ in number of neutrons in mass number due to difference in their difference in number of neutrons. Okay, look here for this problem or this question. S1632 and S1633 are isotopes of sulfur. Use your knowledge of protons, neutrons, and electrons to answer the following questions. Describe how these isotopes of sulfur are the same and how they are different. For the similarities, they are same because they are atoms of the same element, S, sulfur. They are same because they have the same ID, same proton number, same number of protons, okay? Same atomic number, okay? Equal 16 in both. But differ in what? Differ in mass number due to difference in number of neutrons, okay? We can write here same atoms of the same element, okay? Same, they have same atomic number or proton number equal 16. What about differences? They differ in different in mass number, okay, due to difference in number of neutrons, okay, 16 and 17 respectively, okay. Then isotopes. From this discussion, we can define exact definition for isotopes. And they are different atoms of the same element, like example sulfur, same element, that have the same number of protons, ID, proton number, but different numbers of neutrons. different number of neutrons. That's the exact definition of isotopes. Look, please. Second example, hydrogen. Hydrogen has three forms, three isotopes. Hydrogen H11, H11, called protium, protium. Okay, it is called protium. Hydrogen 2, H12, hydrogen 3, H13. Okay, here H12 called deuterium, H13 tritium, tritium. Both forms of hydrogen, second form, third form, are heavy hydrogen. Heavy hydrogen. They are found in heavy water in deep oceans and seas. Okay, the hydrogen of water in deep oceans and seas considered from the isotopes of hydrogen that are heavy, deuterium or tritium. Okay, look at protium. Protium, at the center, there is nucleus only containing one proton, one particle, subatomic particle, one proton, no neutrons. The only atom that has no neutrons, okay, at all, is called protium, H11. Okay, the simplest form of any atom is hydrogen of the first isotope H11. Okay, why? Here, H12 means number of neutrons equal 1, number of protons still 1, so 1 neutron, 1 protons. This nucleon number 2. Okay, here for nucleon number 3, 1 proton still for the ID of hydrogen, 1 proton and 2 protons. Here, the number of protons double or twice the number of protons in this atom. Okay, let's see something interesting. Look at the sample of K. K, potassium. K, potassium. Look at the periodic table for potassium. Potassium found in group 1 in periodic table. Let's magnify this figure. Potassium 1939. 1939. Okay. Look at potassium. What about use the periodic table to find atomic number? Atomic number equal number of protons, the ID of the element. Mass number or nuclear number equal summation of protons plus neutrons. Since the charge is 0 for any atom, the net charge of this atom equals 0. Why? Because number of protons equal number of electrons. All atoms are neutral. Okay. Look here. Atomic number of potassium equal 19. From the periodic table equal 19. What about mass number? Equal 39. So proton number equal 19. Number of neutrons equal 39 minus 19 equal 20. Sorry. Number of electrons equal 19. As number of negative electrons equal number of positive protons. So they cancel each other. So the atom is charged with 0. No charge. No charge. Okay. Look at the second form of potassium. Potassium atomic number still 19. Still 19. Mass number equal 40 in this isotope. Number of protons still 19. Okay. And what about number of neutrons? 40 minus 19 equal 21. Okay. Here, there is difference in number of neutrons. So they are considered isotopes of potassium. Potassium 20 and potassium 21. Okay. What about number of electrons? Still 19. Number of electrons with negative charge equal number of protons with positive charge. So the net charge of this atom equals 0. Okay. What about chlorine? Third example, after sulfur, after hydrogen with 3 isotopes, here chlorine with 2 isotopes. Chlorine 35 and chlorine 37. Okay, 2 forms, 2 isotopes of chlorine. Look at 17. We distribute these electrons, 17 electrons, in shells in energy levels outside the nucleus called energy levels. This energy levels, the first shell contain 2, second 8, so 2 plus 8 equal 10. Out of 17, the remaining electrons equal 7. So chlorine found in group 7, okay? Group 7 in periodic table. Look at both configuration of electrons, the distribution of electrons in different shells, the same for both isotopes. Also, the outermost electrons, 7 in both, they are equal. They behave with the same manner, okay, in both isotopes during chemical reactions, okay? So, look, these isotopes of the same element have the same chemical properties, chemical behavior, okay? They tend, each atom of chlorine tended to gain 1 electron to allow the 7 electrons to be complete with 8, like inert gas, nearest inert gas, like argon, for example, 18. So here, isotopes of same element have the same chemical properties. Why? Because they have the same number of outermost shell, equal 7 in this example. Huh. What about because they have the same number of electrons? As you know, in chemistry, in traditional chemistry, normal chemistry, the chemistry due to behavior of electrons during chemical reactions, either gain electrons or lose electron or share electrons. This is the chemistry, okay? The chemistry of any reactions in our syllabus according to the behavior of electrons during this chemical reaction, during battle between atoms, okay, of elements or compounds. Look, please. Here, number of protons still 17, the ID of chlorine in both forms. Number of electrons still 17 because all atoms are neutral. Number of positive equal number of negative charge. Number of neutrons subtract what? Subtract 17 out of 35 equal 18. Okay, in chlorine 35. In chlorine 37, we subtract 17 out of 37, so the remaining equal neutrons equal 20 neutrons. What atomic number? Atomic number equal proton number equal 17 in both. Mass number differ due to difference in number of neutrons. Here 35, here 37. It's okay. And therefore the same electronic configuration. Configuration means distribution of electrons in different shells away from the nucleus, okay? Look also, we measure the mass of this golden, beautiful golden ring by certain balance, sensitive balance, digital balance, okay? What about mass of atoms? We measure mass of atoms not with balance. We measure them, these atoms, with relative atomic mass. Relative means in relation to something different. Relative atomic mass, AR, symbolized by AR. Relative atomic relative mass, okay, is the mass of an atom, one atom of any element, of any isotope, compared with 1/12. 1/12 means 1 over 12 of what? Of the mass of an atom of carbon 12. What about mass of carbon 12 equal 12? Okay, so 1/12 of 12 equal 1 unit, 1 atomic unit, 1 atomic unit, okay? So look at this scale. What is carbon 12 scale? Use carbon 12 scale as reference standards. This reference, carbon 12, is reference for measurements of relative atomic masses of all periodic table atoms of different 118 elements. Okay, we use carbon 12, the most stable isotope of carbon, carbon 12. The reference standards. Look here, for example, when we measure the relative atomic mass of magnesium. One atom of magnesium. We put it on this pen, guess, on this two-pen balance. Okay, one atom of magnesium equal how many atoms of carbons? Two atoms. Why? Because magnesium equal 24. Its mass equal 24. Means two atoms of carbon 12. It's okay? This relative atomic mass of magnesium. What about isotopes? Isotopes calculations. Isotopes calculations. Here, for example, we will take chlorine as example in this calculation. Okay? There are two common isotopes of chlorine. Calculate the average relative atomic mass of chlorine atoms. How? How we obtain this average relative atomic mass of chlorine? Look, chlorine in nature found in two different isotopes, chlorine 1735, chlorine 1737. Okay, chlorine 35, chlorine 37. What about number of protons? 17, 17. They differ in number of neutrons, 18 here, 20 here. What about percentage? Percentage abundance of both atoms in sample in nature. Okay, abundance in nature, percentage abundance. Say we obtain 100 atoms, but before this point, look please at periodic table. Here periodic table. In group 7, chlorine 17, electron configuration 287. So the outermost energy level contains 7 electrons. So chlorine lie in group 7. Okay, this represents group number. Outermost electrons of outermost shell represent group number of the elements. Here, chlorine found in group 7 in periodic table, extreme right side of periodic table. Look at chlorine now. What its mass? 35.5. From where this figure came from? 35.5. Here, 35. Either 35 or 37. How is this figure? From where? It came. From where? Look, this accurate relative average relative atomic mass, from where this figure came. How we obtain this figure? Look, please, to calculate the average, we need certain calculation. Look, for example, we have sample of chlorine. This sample contains 100 atoms only of chlorine, 100. 75 of this 100 out of 100 from isotope, light isotope 35. And the remaining atoms, I mean 25, from heavier isotope 37. Okay? What about relative atomic mass? Belong to which one? 75% or 25% of heaviest isotope? Look, please, average equal 75 times 35, okay, plus 25 times 37 divide 100. Why divide 100? Because this percentage, as you know, to calculate percentage of anything, A over B times 100. Now we return this percentage into normal number. So we divide, not multiply. So we divide by 100 to obtain. By your calculator, you can check this figure, equal 35. Log 35, like here exactly. Okay. Next video, inshallah, we will solve a lot of problems about calculations of isotopes. Okay. I'm waiting you. Here, before finishing our class, in new syllabus, just this figure this omitted from the old syllabus the usage of isotopes in our life. The isotopes has a lot of uses in our life, in industry, in medicine, in tracing diseases. Here, just a hint to know what we why we interest with isotopes. If they are useful, yes, useful um, in many ways in our life. Here, a patient being injected with radioactive isotopes to find location of certain tumor in his or her body. Okay, in this device, MRI. Okay, before going inside, this patient injected with certain isotope. Okay, to locate this tumor if present. Okay, thank you. With my best wishes, see you next video, inshallah, about problems on isotopes. Bye bye.